This is modern frame scaffolding. It provides a safe, efficient way to build a temporary structure for an endless variety of construction situations. The key word in temporary structure is structure. A scaffold has to be able to support its own weight, plus the weight of equipment, materials, and workers, and it could be your life that it's supporting. It needs a solid foundation, rigid construction, solid walking and working surfaces, safe access, and fall protection. Frame scaffolding may vary somewhat from manufacturer to manufacturer, but there are more similarities than differences, and the essentials of scaffold erection apply to all of them. On the other hand, if it's not done properly, it can be hazardous to mix scaffold parts from one manufacturer to another. This is particularly critical for tall scaffolding, and any scaffold that's going to bear significant weight should be evaluated by a competent person to make sure it will support 4 times the maximum load you'll put on it. If it's up to you to decide what scaffolding to put up, your first consideration is selecting the size and style of frames for your application. If you need access along a run of scaffolding, you would use these open-ended or walk-through frames. Tall units will get you up faster, and intermediate units give you options to adjust the height of your work platform. A little pre-planning and the right combination of frames will keep you from having to work in an awkward or dangerous position. Cross braces are designed for specific frame sizes. The correct cross bracing controls the length of the frames so that they'll stack uniformly and take standard lengths of planks. Scaffolding has to accommodate a lot of very different situations. Manufacturers have introduced a variety of equipment to give you lots of options for your project. Often, the solution is somewhat creative, but that doesn't mean that it's ever acceptable to introduce any hazards into the system. Any variations on the system or judgment calls need to be made by a competent person. When we talk about a competent person, we mean someone who has had experience with the scaffolding system, is capable of identifying existing and predictable hazards, and has the authority to take prompt corrective action if there's a hazard present. Before you begin erecting any scaffold, you need to make a careful assessment of the site. If you're going to be working on an existing floor or deck, what kind of shape is it in? Is it sturdy enough for a fully loaded scaffold? Is it smooth and level enough for a rolling scaffold? If you're working on the ground, what are the bearing conditions? Any excavation, loose fill, or unstable soil will have to be leveled and compacted before building a scaffold on it. You should always use a base plate on a scaffold leg. It gives you a flat bearing surface and will keep the tube from getting deformed. On compressible surfaces like soil or asphalt, a base plate alone may not be sufficient. Soil that's dry and solid one day can be mud the next, and heat will soften asphalt. That means using a timber sill to help distribute the weight. Level the ground so the sill has uniform contact and the weight can be distributed over the whole area. If there are depressions you can't fill adequately, don't use wood scraps, plywood, or concrete blocks for leveling. They may look convincing, but none of them are adequate for serious bearing. Instead, use wood cribbing or extensions approved by the manufacturer. A continuous sill between frame legs will give uniform support and provide a surface for nailing the base plates to keep them centered. The effort you put into a good foundation will pay off in faster, easier erection and a safer installation. Poor bearing is difficult or impossible to fix once the scaffold system is in place. You will rarely get the sills perfectly level. Using screw jacks on the first run of scaffolding allows you to adjust for differences in level or elevation. If the ground has a noticeable slope, start assembling the frames from the high point. Start the first jacks a little above their lowest adjustment. Insert a base plate or a screw jack with a base plate on each leg and tilt the frame into place. If the scaffold is going to be more than 1 frame high, this is a good time to make sure that the top of each frame leg has a coupling pin. Attach the cross braces to the frame. Most manufacturers have some form of self-locking stud to secure the brace. Make sure the brace is fully seated and the locking mechanism functions properly. If one is bent or unusable, don't attempt to rig something in its place. Put the frame aside for repairs and use one that works. Once a set of frames is assembled, adjust the legs until it is roughly plumb, level, and square before attaching the next frame. If it's out of square or not plumb, you're going to have to fight with the rest of the frames and the decking to get them to fit correctly. If you start right, it stays right. Continue this process until your first run is complete. Then go back over the assembly and make any adjustments necessary to bring the units into alignment. This is a good time to nail down the base plates to keep them centered on the sills. Once the frames are secure, you're ready for planks. Scaffold planks can be made from aluminum, steel, laminated wood, or scaffold-grade timber. All fabricated planking must be certified for use on scaffolding, and timber planks should be at least 2 by 10 and stamped scaffold grade. Even with these certifications, you should look your planking over before you use it. Scaffold planks take a lot of abuse, and it's up to you to make sure they're still serviceable. All planking should be clean and clear of slip and trip hazards like ice, snow, paint, concrete, oil, or debris. The shape of metal planking is what gives it its strength. If it's bent or deformed, it should be replaced or set aside till a competent person has had a chance to inspect it. Wood planking should remain free from warping, cracking, splitting, or open knots. Some checking on the ends is acceptable, but if there's deep checking, over 6 inches, it should be inspected by a competent person before it's reused. Planks should extend over the frames at least 6 inches, but no more than a foot. If they're less than 6 inches over the frame, they must have a cleat to keep them from sliding off. Planks that extend out more than a foot could tip up off the frame if someone stepped on the end. When you're doing a run of planks, they should overlap at least a foot. During erection, it's a good idea to use at least 2 by 10 planks for an extra margin of safety. When you assemble the next level of scaffolding, stage the materials so you can reach them easily without losing your balance. One solution is to hang the frames on the outside coupling pins. Braces can be laid across the frames next to the pins. Set the frames on the pins and attach the cross braces. When you're working up off the ground, don't try to attach the braces by standing in the middle of the scaffold. Do it from each end, supporting the braces on the opposite frame. This is much more stable and gives you something to hang on to. If there's any chance of uplift on the scaffold assembly, like unusual loading or wind forces on temporary weather protection, the frames and pins should be locked together. Manufacturers have a variety of hardware for this. Staging materials gets more complicated once you get above the second tier of scaffolding. If you're handing materials up from person to person, make sure that everyone has stable footing. Stand near the end frame and stay behind the cross braces for an extra measure of safety. In certain situations, a forklift or other hoisting equipment, such as a rope and pulley, can provide better and faster access to the materials. You're ready to build the work platform when the scaffold is high enough to reach the work area. The platform has to be solidly planked and at least 18 inches wide. Depending on the height of the platform and the work being done, you may have to provide fall protection. The OSHA rule is that each worker on a scaffold over 10 feet from a lower level has to be protected from falling to that lower level. There are a variety of options for providing fall protection. One common type of fall protection for scaffolding is a guardrail system, complete with top rail, mid-rail, and toe boards. Most manufacturers have guardrail systems that consist of uprights and guardrails that can be used as top rails and mid-rails. Set the top rails between 36 and 45 inches off the deck, and the mid-rail about halfway between the deck and the top rail. Toe boards should be made out of 1x4 or heavier material and fastened securely around the entire perimeter of the deck. You can use other materials besides a manufactured system, such as 2x4s or cables, but a competent person has to supervise their installation to make sure they conform to the minimum requirements for fall protection. If the nature of the work or your scaffold configuration is such that you can't provide a complete guardrail system, a competent person must determine if you need supplemental fall protection. Platforms require some form of safe access, either through an opening in the deck, through an end frame, or access through an adjacent structure. There are end frames with built-in ladders and ladder sections that attach to the frames. Whichever you use, they need to extend at least 3 feet above the deck being accessed. And end frames that are a part of a landing should have a gate that swings inward onto the platform. There are also stair units that are designed to fit inside a scaffold tower. Trying to climb open frames or cross braces is an invitation to disaster and should never be permitted. As you build a scaffold higher, you need to think about stability. The rule is, if the height of a scaffold is more than 4 times the width of the base, it needs some form of bracing. Usually, this means tying the scaffold into the adjacent structure. Because structures present so many different situations, tying into them often requires experience. A competent person should supervise the process. Ties need to be braced so they provide resistance in both directions, and the braces themselves need to be secured so they won't fall off if a tie becomes slack. Common braces are pipes and clamps that can be configured to provide a rigid attachment or number 9 wire twisted tight against a restraint. Some common techniques are attaching to exposed structural members through openings such as windows, to friction devices such as screw jacks that are set in openings, or to anchors set in the structure itself. For frame scaffold over 3 feet wide, OSHA requires ties at least every 26 feet vertically on both ends and every 30 feet horizontally. Scaffold frames 3 feet wide and narrower have to be tied off vertically every 20 feet. If the scaffold is subject to heavy loading or wind forces, additional bracing may be required. Another common scaffold system is a rolling tower. These are built just like conventional scaffolding, with the same requirements for safe access and fall protection, with a few exceptions in assembly techniques. Instead of base plates or screw jacks, each leg is set on a heavy-duty caster. A special brace is used diagonally to keep the frames rigid and square with each other, especially when the scaffold is being moved. The same 4-to-1 height-to-base ratio applies. The height can be extended slightly by adding outriggers at the base, but there is a practical limit to how high a rolling scaffold can be built. Remember that the wheels should always be locked down when it's in use, and make sure equipment and personnel are off the scaffold while it's being moved. Once a scaffold has been erected, it should be inspected frequently to make sure that the system is intact, particularly that there isn't any settling at the foundation that's pulling the scaffold out of plumb or putting extra strain on the ties, that the ties to the building are intact and have the proper tension, ladders, planking, and platforms are secured, there are no loads that are causing the planks to deflect 1.5 inches or more in a 7-foot span or 2 inches in a 10-foot span, and the work areas are free from obstructions or debris. Dismantling a system is one of the most critical periods in scaffolding, and it's a time for special concern. Before dismantling a scaffold, inspect it again carefully. Look for braces that have been loosened or removed, loose decking, or planking with concrete or debris. Things that aren't a big hazard when the scaffold is in place could quickly become a hazard when it's coming down. This is no time for surprises. Take the system apart methodically, making sure everyone is well positioned and has good footing. The people working on top need to be aware of the people below at all times. Never drop scaffold materials from any height. You could damage the materials or cause a serious injury. If planks have been removed while the scaffold was in use, make sure they're replaced now. Leave ties to the building in place until you're removing the scaffolding on that level, and then make sure that there are an adequate number of ties below you to support the remainder of the structure. There's no percentage in getting rushed and careless. Taking a scaffold down is always faster than putting it up, and you're never wasting time by being careful. While a scaffold is being erected or dismantled, there are always moments when key elements are missing. This means you have to stay alert and use extra caution during these processes. Modern frame scaffolds are engineered to provide safe access and work areas for the people who use them. If you follow these guidelines and the manufacturer's recommendations, your completed scaffolding should be a safe and secure structure to work on.